21st of January 2025, Defense Research Development Organization or DRDO successfully conducted a 120-second ground test on a Scramjet engine, showcasing its potential for use in the hypersonic missiles. This marked a pivotal moment in India's defense sector, demonstrating the potential of nation to develop advanced defense systems that can operate at unprecedented speed. But this raises a couple of critical questions. What are hypersonic missiles and scramjet engines? Why are scramjet-powered hypersonic missiles necessary for modern warfare? And most importantly, how will this milestone impact India? Let's delve deeper into these questions in this video. Missiles can be classified based on various types such as range, launch type, and propulsion. In terms of range, they can be short range, long range, or intermediate range. Launch mode includes surface to surface, air to air, and surface to air missiles. One key classification is based on propulsion, which includes solid, liquid, hybrid, scramjet, and ramjet engines. This brings us to an important question. What is a scramjet engine? A scramjet engine is a type of jet engine that doesn't need a compressor or turbine to carry out compression. Let me break it down for you. A typical jet engine has three main parts: a compressor, combustion chamber, and turbine. To begin with, air first enters the compressor. Here it is squeezed into a smaller space, which increases its pressure. This high pressure air then moves into a combustion chamber. In combustion chamber, it is mixed with fuel and ignited, causing rapid expansion of gases. These gases then flow through turbine, spinning its blades. Now these blades are connected to the compressor by a single shaft, so when the blades rotate, the compressor also spins. Finally, these gases exit at very high speed, creating a thrust which propels the aircraft. Now a scramjet engine, unlike a typical jet engine, does not have compressor and turbine. Instead, it relies on incoming air for compression. Imagine sticking your hand out of a car while driving. When the car is low, your hand won't feel any pressure. But when you increase the speed, you will feel a lot of backward force exerted on your hand. This is similar to how air is compressed when a vehicle moves rapidly. So on 21st of January 2025, combustion process of this scramjet engine was tested. Specifically, the engine was analyzed to see if it could ignite and sustain stable combustion at very high speed. So this brings us to the question, what challenges are usually encountered when attempting to perform a combustion test of scramjet engines? There are two difficulties that are usually faced in this process. The first one is to achieve stable combustion at supersonic airspeed. Air enters the combustion chamber and flows through it at very high speed. The time duration for which air remains inside the chamber is known as residence time. As this residence time in scramjet engine is very lesser, maintaining stable combustion is as difficult as keeping a candle lit in a hurricane. The second challenge is to maintain thermal cooling amidst high temperatures. During the compression process, when the molecules collide with each other, they release massive amount of energy. Apart from this, the combustion process itself releases lot of energy, leading to temperature rise inside the chamber at extreme levels. To resolve this, scientists came up with two innovative solutions. The first one is to use indigenously developed endothermic scramjet fuel. As this fuel is endothermic in nature, it absorbs the heat and cools down the engine, making the combustion process efficient. Second solution is the use of ceramic thermal barrier coating, which can withstand extreme temperatures even beyond the melting point of steel. So this leads to the final question, why are scramjet engines called the heartbeat of hypersonic missiles, and why are countries like the United States, Russia, China and India actively pursuing this technology? During the wartime, speed is essential and hypersonic missile fulfills this need. These missiles can respond to enemy strikes and can reach their target rapidly by traveling at a speed which is 5 times faster than the speed of sound. To master hypersonic missiles, developing scramjet engine technology is essential. To carry out combustion at higher altitudes, an engine needs to carry oxidizer so that it can mix oxygen with fuel for combustion. Since scramjet engines rely on air from the outside, they do not need to carry an oxidizer. Moreover, since scramjet engines do not have moving parts, their design is more compact and simple. Lastly, perhaps most importantly, scramjet engines provide the ability to deliver payloads rapidly. Hypersonic missiles are crucial not only for a nation's security but also for boosting economic growth, for expanding manufacturing capabilities and driving engineering innovation. The development of advanced materials used in these missiles can lead to multiple breakthroughs not only in defense sector but also in commercial aviation and space exploration. Nations that have developed this technology will always maintain a significant advantage during the wartime, and this is why countries are in a race to develop this technology. So that's all from our side for this case study. I hope you found something valuable and informative in this video. If you do, please like, subscribe and share. I'll see you in the next video. Till then, bye bye.